Okay, and you have to do it to 2 decimal places. All right, so what we would do, afternoon, we would observe that this is 7.21 over 0.038, like that, and we realize that this 721 has to be, sorry, this 0.038 has to be converted into a whole number. Okay? So it means then that this will become 38, because we move the decimal place 1, 2, 3 spaces to the right. And therefore, we'd have to do the same thing up here. So if we move this 3 places to the right, it becomes 1, 2, and we'd have to put in a 0. Okay? So it'd be 1, 2, so it'd be 7, 2, 1, 0. Seven two one zero over 38. So how do we deal with that now? The number on top goes inside of the bracket, so this becomes 7210, and we have to divide that by 38. Okay, so how do we divide 7210 by 38? Say 38 into 7 cannot, 38 into 72. All right, so what you could do, you could write down 38 by 1. Hi, afternoon. 38 by 2, 38 by 3. So if you didn't have the use of your calculator, you just work this out and see what it comes out to be each time. All right, and then that will help you to know what goes in there. So 38 by 1 is 38. 38 by 2 is 76. And 38 by 3 is 114. So you can check it, double check it. Right, so that's correct. So from here so far, 38 into 72 will go how many times? Once, right? It can't go 2 because it's too much. So you go 38 into 72 will be 1. 1 by 38 is 38. 8 from 2 cannot, you borrow from the 7, so this becomes 6. And that becomes 12. 8 from 12 is 4. 3 from 6 is 3. Okay? So the next step is to bring down the next number in line, which would be the 1. So that comes down here. So you end up with 38 into 341. So from here, you'd see that you'd have to go quite a bit more. Okay? Let's try 38 by 5 is 190. 38 by 8 is 304. 38 by 9 is 342. So we'd have to say 38 by 8. Right? Because 38 multiplied by 8 is 304, right? So 304, right? And that will be what you put here. 8 by 38 is 304. All right, and you subtract 4 from 1 cannot, you borrow. This becomes 3 on top. You carry the 1. 4 from 11 is 7. 0 from 3 is 3. 0. Okay? Then what's the next step there? You say 38 into 37 cannot. You bring down the 0 as the next number in line. So this becomes 370. Okay? 38 into 370. You have to go back and see. All right, let's try 9. 38 by 9 is 342. So if we say 9 by 38 is 342, what happens from this? What happens here? This becomes 6, this becomes 10. 2 from 10 is 8, 4 from 6 is 2, 3 from 3 is nothing. So you have 28 there. But what's the next step now? What you'd have to do is notice that the point is here, and we have to carry that point up to this position. And then we say 38 into 28 cannot. Now what comes after here are zeros. So you bring down one of the zeros here, so you get 280. 38 into 280. And you have to see what is the nearest number that could go into that. Right, that'd be 7. 38 by 7 is 266. So you come here, 7 by 38, 266. Right, then you say 6 from 0 cannot, you borrow from here, so this is 7, that becomes 10. 6 from 10 is 4. 6 from 7 is 1. So you have 1, 4. Right, again, and you keep going that way. And they had said how many places? 2 decimal places. So which means that you have to go to the 3rd decimal place in order to solve this problem. Because you need the 3rd one to let you know if you have to round it up or down, or leave it as it is. So you bring this down. 0. 38 into 140. That looks like 3. So you put the 3 here. 3 by 38 is 114. Right? 140 subtract 114. 3, 10. That's 6. That's 2. Right? And then again, the next thing you have to bring down is the next 0 here. Right? And you say 38 into 260. I think that'll be 6. 228. So if you try 6 here, you get 6 by 38. 6 multiplied by 38 is 228. And that's what you're going to use here, 228. Because it's 6. Right? And that will come down to be 2 and 3. But what are you going to put the answer as? If you have to go to 2 decimal places, now you could make a decision, because this number is 5 or more. So this here will become 189.74. Let's see. 7.21 divided by 0.038, 189.74. Okay? So that's the procedure that you would use to do that problem. Okay, any questions on that? You okay? You clear on that? Excuse, you clear on it? It's okay? All right. So what we do, we go to the next one. What other questions we had? Okay, so the last linear equation we had looked at was x over 6 equal to 5. That's the last one we had studied. Okay, x over 6 equal to 5. But that wasn't a really tough one. We start, the next type of equations we're looking at are these. 5x minus 3 is equal to 2x plus 9. 5x minus 3 is equal to 2x plus 9. This is an example of the next type of problem we'll be looking at. Now, the strategies that we're going to use here to solve this is really two strategies. What we'll try to do is to remove all the x's from one side, right, and have only x terms on a particular side. So that is to say, like in this example that we're looking at here, we could make a decision that we want to have all the x terms on the left-hand side. Okay? On the left-hand side. Somebody might say they want to have all the x terms on the right-hand side. That would be equally okay. It's not a problem. But you have to make that decision. The best way to look at it is to always get the x terms on the side where initially it has the largest value. So for example, in this case, the x term's largest value is 5x. So what our strategy will be is to end up with all our x terms on the left-hand side of the equation. Okay? On the left-hand side of the equation. The other thing we have to do, we have to note when we're doing these problems of this type, is that we try to eliminate or remove whatever is furthest away from the x first. We do that first. In other words, we are going to deal with the minus 3 first in preference to the 5, right? In order to get x by itself. The whole idea is to get x by itself on one side and everything else on the other. So the procedure would be, first of all, let us get all the x terms on the left-hand side and remove them from the right-hand side, right? Let's bear that in mind. So what we'll do first is we'll remove the 2x from the right-hand side so that we would not have any x terms on the right-hand side at all. So we'll have 5x minus 3. I'm going to put an equal sign here. I'm going to put 2x, and I'm going to put minus 2x right next to it. Why am I putting minus 2x right next to it? Because remember, the idea is to get rid of all the x terms on the right-hand side and only to end up with x terms on the left-hand side. So to get rid of this 2x, we have to minus 2x, the opposite of what it is. But this plus 9 is unchanged. We didn't do anything to that, so I'll just write it back like that. But remember, we learned that whatever you do on the one side, in order to maintain equality, you must do it on the other side, the exact thing. So if this is minus 2x here, I'll also have to minus 2x on this side as well. Okay? And what will happen is that the 2x and the minus 2x will cancel out, which is what we wanted to have happen anyway. That was our objective. And we end up with just plus 9 on this side. But what you observe is you have 5x minus 3 minus 2x. And if we consider the 5x and the minus 2x, 5x minus 2x is really 3x. If you have 5 apples and you give away or you take away 2 apples, you'll only have 3 apples. X represents something. So you could call it anything. You could call it pencils, apples, dollars. So if you have $5 and you give away minus $2, you end up with $3. But don't forget, you still have the minus 3 there. So we put that back. That's equal to 9. So we have accomplished the first thing that I mentioned, which was get rid of all the x terms on the right hand side and only end up with x terms on the left hand side. Are you seeing that here now? Only x terms on the left hand side. There's none on the right hand side. So the next thing I mentioned is that in order to solve for x, it means get x by itself on one side and everything else on the other. And in order to start to get towards that point, we have to deal with whatever is furthest away from the x term. And the thing that is furthest away from the x term is the minus 3. So we're going to deal with that first. So you have 3x minus 3. And what is the opposite of minus 3? Plus 3. So I'm going to plus 3 here. Because I know when I plus 3, that plus 3 will remove the minus 3 from the left hand side. Not so? It's the opposite. It's called the additive inverse. You're going to remove it. 9 is there from before. But we learned that if we do something on one side of the equation, we have to do the same thing on the opposite side to maintain the balance or the equality. So if this is minus 3 plus 3, what we did, we added the 3 here. Then we have to do the same thing here. Add 3 on this side as well. So what happens here is that the minus 3 is going to cancel out with the plus 3, which we intended to do anyway. And look what happens. You get 3x now. So we are getting closer to our objective, which is to get x on one side and everything else on the other. 9 plus 3, 9, 10, 11, 12. So that's 12. Okay? So 3x equal to 12. Therefore, we should be able to find what x is. But let's see what we do. This is really 3 multiplied by x equal to 12. But we know we want to end up with x by itself. So we have to do the opposite of multiplying by 3. What's the opposite of multiplying by 3? Divide by 3. So what we're going to do is we're going to divide this side by 3. And whatever we do on one side, we have to do it on the other side. So what happens here is that this 3 into 3, 1, 3 into 3, 1, 3 into 3, 1, 3 into 12, 4. So are you now seeing that on this side we just have x, because x by 1 is x, divided by 1 will give me back x, and this will be equal to 4 over 1, which is 4. So x is equal to 4. Now if we wanted to know if what we did was correct, all we'd have to do is take the value of x, place it back into the top equation, and if we have solved the problem correctly, then we should get the left-hand side of the equation working out to be equal to the right-hand side of the equation. That's what solving means. Solving means find the value of x that when substituted into this equation, then the equation is satisfied. That is to say, the left-hand side of the equation is equal to the right-hand side of the equation. So just as a quick check, let us see if what we did is correct. Let's check it and see. X equal to 4, put it into the equation. So if we take x equal to 4 here and substitute it into this equation here, what happens? Let's see what happens now. Just as a check. What happens? You get 5 multiplied by 4. Notice the use of brackets there to mean multiply. Minus 3 should be equal to 2 multiplied by 4 plus 9. Clear on that so far? Just put in 4 for x. It should be work out. Let's see. 5 by 4 is 20 minus 3 should be equal to 2 by 4, which is 8 plus 9. Let's see if that's working out. 20 minus 3 is 17. So the left-hand side of the equation is 17. And we need to find out if the right-hand side is also 17. Let's see. 8 plus 9 is 17. So seeing that both the left-hand side of the equation is equal to the right-hand side of the equation, then we know that our solution is correct. 4 is the value for x. Okay? Questions now. What questions we have? What questions we have? You get to practice, right? You're going to practice 1 or 2 in the class. But do you have any questions now? Yes. We're trying to get all the x terms, the terms with x on the left-hand side, which means we must remove them from the right-hand side, the other side. Okay? And in order to determine which side is the best side to get it onto, we look to see which side has initially the larger value of x, which is the left-hand side in this case. Good? Some students and some teachers say, always get all the x's on the left-hand side. You could choose to do that way as well. It's just that in that case, you'd often, or you may have to deal with negative terms. All right? As you would see when we'll do our next example. Okay? Any other question? No? Okay, so take it down. And then I'll do our next one. And then I'll give you one to try in this light. Okay, so the next one we're looking at is 4x plus 5 equal to 2x minus 8. Right, let's see how that one would go. Let's see how that one would go. And we say, in this case, we have the same situation where the larger value of x is on the left-hand side. So we're going to, our objective is to get rid of all the x terms on the right-hand side and only end up with x terms on the left-hand side as the first order of business. So let's deal with that. So we have 4x plus 5 is equal to 2x minus 8. So if I want to get rid of 2x on this side, what do I have to do? I have to take it away. So I'm going to minus 2x here. And if I minus 2x here, what do I have to do here? Minus 2x as well. Okay? So what in effect happens is that this 2x and this minus 2x cancel out. And I end up with 4x minus 2x. 4x minus 2x is what? 2x. So I end up with 2x plus 5 is equal to minus 8. 2x plus 5 equal to minus 8. What's the next step that I have to do? Right? Right, because the idea here is to get x by itself, but we cannot deal with the 2 first. We have to deal with what is furthest away from it first. So we have to deal with the plus 5. And that means we have to get rid of plus 5. So you have 2x plus 5. Take away 5 now, because we have to get rid of this plus 5, which means we have to minus 5. And if we do that on this side, we also have to do it on the other side as well. So you end up with 2x plus 5 minus 5, this cancels out, is equal to minus 8 minus 5. So this works out to be 2x equal to minus 8 minus 5. It's minus 13 because we have to add the numbers and keep the common side. So this would be minus 13. Then we observe that this is 2 times x. So the opposite of multiplying the x by 2 is dividing the x by 2, like this. And if we do that on the left-hand side, we must also do it on the right-hand side. So I divided both sides by 2. It will cancel out here, and I'll get what x is. X now will be equal to minus 13 over 2, which is the same thing as saying minus 6 and a half. Minus 13 over 2 is the same thing as minus 6 and a half. Okay? If you didn't do the fractions problems, you'd maybe get a little challenge here. So that's why you see it's modular, we're building up to it. So if you were to take x equal to minus 6 and a half and substitute in here, you would see that the left-hand side would be equal to the right-hand side. But we're not going to do that. In the exam, you wouldn't have time. So you just go ahead and you make sure that what you did is correct. Any questions on this one? Okay. So I'll put up one for you that will be a little different. Well, let's see how you go with it. evening. Okay, so I'd like you to do this one first. Do this one here first. Do that as number 1, and then do this one here as number 2. Okay, do it in that order for me. Okay, so we're going to look at the first one, 7x minus 1 equal to 3x plus 4. Right, so 7x minus 1 equal to 3x plus 4. If you observe on the left-hand side has a larger x, so it means that we're going to try to get all the x's on to the left-hand side. And that means we have to take away 3x from the right-hand side. So if we have 7x minus 1 is equal to 3x plus 4, we're going to minus 3x from the right-hand side, and therefore we're going to minus 3x on the left-hand side as well. So what is going to happen is that you're going to have 7x minus 3x is 4x. The minus 1 is still there, and that's equal to the 3x minus the 3x. We know that we wanted to get rid of it, so that's why we did it in the first place. And then we have plus 4 on this side here. So what's the next step? The next step here is to get rid of the minus 1, right? Because that's what's furthest away from the 4x. So we're going to say 4x minus 1. The opposite of minus 1 to get rid of it is to add 1. If we add 1 on the left-hand side, we also have to add 1 on the right-hand side. So what happens here is this is going to cancel with this. So we're going to end up with 4x is equal to 5. And here this is 4x, which means 4 times x. So we're going to divide 4x by 4. That is, we did the opposite of multiplying by 4. We divide by 4 on the left-hand side. So it means we have to do the same thing on the right-hand side. So this cancels, this 4 cancels with that 4, leaving x equal to 5 over 4 is the same thing as 1 and 1 over 4, or x is equal to 1 1/4. Okay? So look at it and let me know what you think. Okay, so there are 2 ways we're going to approach this. The first way we're going to approach it is the way based on what I had told you all initially. And that way was observe which side has a larger x in the first place. And then try to get all the x terms on that side and remove them from the other side. So if we look here, we observe that the right-hand side has a larger x, it's 5x. So what, in this case, our objective would be to get all the terms, x terms on the right-hand side and eliminate them from the left-hand side. So it means then I'd have to eliminate 3x from this side here. I'd have to eliminate 3x. So I'd have to do the opposite of 3x, so I'd have to remove it, which means I'd have to say, put back the initial 3x plus 7, but I'm now going to minus 3x now. minus 3x. Okay? And if I do it on this side, which is the left-hand side, I have to also do it on the right-hand side as well. So what happens here is that this 3x is going to cancel out with the minus 3x, so I'm going to end up with 7. And this is going to be equal to 5x minus 3x, which is 2x minus 1. So what is going to happen now is that if we look at where the x term is, we observe that we want to deal with what is furthest away from it. So we're going to deal with the minus 1 first. We're going to deal with this guy here, And how do we deal with him? It means we have to get rid of him. So we're going to end up with 7 is equal to 2x minus 1 plus 1 to get rid of that. But if we plus 1 on the right hand side, we have to also plus 1 on the left hand side. So I'm going to plus 1 here. 7 plus 1. This is plus 7, right? So plus 1, I just write it here because I couldn't fit it here. So it's plus 1 plus 7. So this is plus 1 plus 7 is 8. And the minus 1 cancels out with the plus 1 on the right hand side. So we end up with 2x. Then what happens now? We want to get rid of the 2 multiplied by x. So we want to get rid of that 2. So we're going to do the opposite of 2 multiply, which is divide by 2 on the right hand side. And if we do that on the right hand side, we must also do it on the left hand side to maintain equality. I did this for a purpose because I wanted to get x. So I'm getting x there on the right hand side. And 8 over 2 is 4. So if 4 is equal to x, it means then that x is equal to 4. So the answer is x equal to 4. Did you guys get that? Okay. If you didn't get that, it would probably mean that you didn't follow the instruction exactly as I told you to do it, right? However, remember I told you that there were 2 ways to do it. This is way number 1, which is where you always try to get the x on the side of the larger, right? Another teacher might tell you, or you might have tried to attempt it this way, where you're just trying to get all the x terms on the left-hand side like we were doing all the time, right? So if you decided that you wanted to go that way, let's see what happens if we went that way. You're going to introduce negative terms, right? And you have to know how to deal with these negative terms. So I'm going to do one like that just so that you'll have an idea of how you do it. So what happens here is, let's say we decided we wanted to get all the x terms on the left-hand side. What we'd end up with is 3x plus 7 equal to 5x minus 1. But we're going to minus 5x from this side because we decided we wanted to get all the x terms here and remove them from the right-hand side. We want to get all the x terms on the left-hand side. So if we minus 5x from the right-hand side, we'll also minus 5x on the left-hand side. So we end up with 3x plus 7 minus 5x is equal to 5x minus 1 minus 5x. Well, this side is easy to see, the right-hand side, because the 5x cancels out with the minus 5x. But on the left-hand side, we have to deal with 3x minus 5x. And this comes like combining numbers with unlike signs. When there's no multiplication or division present, we learned that we always take the smaller number away from the larger number and keep the sign of the larger, right? That's what we did earlier. So the same things happen here. We're going to take the smaller one away from the larger one, which is we're going to take the 3x away from the 5x. 3x taken away from 5x will give me 2x, but I have to keep the sign of the larger one. The larger one here is this one, so it means it's going to be negative. So you end up with negative 2x plus 7 is equal to negative 1. Now, as I told you, if you go this way, you're going to end up with negative terms. And that's why we were saying your strategy should always be to bring the x terms on the side where you initially had the larger x value. That's why I decided to do it here. If we decided to go against that, then this is the scenario we would find ourselves in. But once you know the mathematics, you can deal with it. Because the next step here is to get rid of the plus 7 because it's furthest away from the x. So you say minus 2x plus 7 minus 7. You're getting rid of the plus 7 by minusing 7 on the left-hand side. So it means you have to also minus 7 on the right-hand side. So what happens is the plus 7 cancels out with the minus 7. So you get minus 2x is equal to minus 1 minus 7 is minus 8. Right? Add the two numbers and keep the common sign. And here, how do we do the calculation here? Well, what we say is minus 2x means minus 2 multiplied by x. So in order to reverse that, we have to divide by minus 2 on the left-hand side. And therefore, if we divide by minus 2 on the left-hand side, we also have to divide by minus 2 on the right-hand side. Because if I cancel this minus 2 with this minus 2, I'm going to get x. Like signs when divided give a positive result, so I'll get positive x there will be equal to like signs when divided give a positive result. Therefore, this answer will be 4. So in both cases, you get x equal to 4. It's just that you have to be more sound mathematically to deal with it here than if you follow the instruction and dealt with it here. Okay? What you'd find is that if you follow the instructions to the T, your life becomes extremely easy. If you don't listen and you go the other way, you're going to have little roadblocks to go through. So you make your choice, whichever one you feel more comfortable with. Right? But you see the difference here. That's a good example of the differences, right, when you follow the instructions to the T. Any questions on that? Okay. Okay, so what is our next equation that we're going to look at? Now, I took a little time to go through this so that the last one, so that you get a good understanding of how to approach it. Okay, we're going to do a next type now. So the next type we're looking at is this one. 2 into 3x minus 5 is equal to 8. 2 into 3x minus 5 is equal to 8. Okay? There are more than one way to do this question. And I'll do it both ways so that you'll see how you can approach it. This question, you always try to deal with the thing that is furthest away from the x. In this equation, if I had to end up with this is the process I would have ended up with if I started off with x. I would have said x multiplied by 3. Then I would minus 5. And then when I worked out that, I would multiply that result by 2. That's the order, right, that you would work it out if you knew the value of x. You would take the 3 multiplied by the x. The answer you get, you had minus 5. And when you calculate all of that, because it's in brackets, you must do that first. Then you would have multiplied by 2. Good? So it means the last thing you would have done is to multiply by 2. When you're trying to solve for x, the last thing that you would normally have done if you was going to work it out is the first thing you have to reverse. Okay? And the first thing you have to reverse is this multiplication by 2 in this question. Okay, so this is way number 1. What I observe is that this means 2 multiplied by 3x minus 5 equal to 8. That's what it means. So because of what we just spoke about, I would eliminate the multiply by 2. I would reverse the multiply by 2 first. So I would do divide by 2 here, and then I would divide by 2 on the other side. Okay? So what would happen is that this 2 would go into 2, 1. This would go into 2, 1. So I'd end up with 3x minus 5 is equal to 4. this is a lot more like what you did before, not so? You can handle this real easy now. Because all we have to say is, let's get rid of the minus 5 because it's furthest away. So you have 3x minus 5 plus 5 on the left-hand side is equal to 4 plus 5 on the right-hand side. What's the next step here? This will cancel. Minus 5 cancels the plus 5. So you get 3x is equal to 9. And therefore 3x over 3 is equal to 9 over 3. Divide by 3 on both sides. So these will cancel. So we'll get x is equal to 3. Any questions? Good so far? Okay. So this is way number 1. But another teacher or you yourself might say, but we know another way that we could do this. And the other way that we know is if we come across here and rewrite the question, 2 into 3x minus 5 is equal to 8. The other way that we know to do this is to use something called the distributive law. What's the distributive law? It means take the 2 and multiply it by everything inside of here. That's the distributive law. In the distributive law, this 2 is multiplied here and is multiplied by here if we want to expand the brackets. We'll do more of that as we go along when we do more algebra. But distributive law says that this 2 is going to multiply by the 3x, so you'll get 2 by 3x, which is 6x, and 2 multiplied by minus 5 is minus 10. 2 by 3x is 6x, 2 by minus 5 is minus 10. And that will be equal to 8. Now, if you recall, this here is very similar to this in structure. So it's basically the same thing we're doing again. So we'll say 6x minus 10. Do the opposite of minus 10, which is plus 10. If you do it on the left-hand side, you must also do it on the right-hand side. So I add 10 here, I add 10 on the other side. Cancel. Minus 10 cancel with plus 10. So I get 6x is equal to 18. Divide both sides by 6. Because I want to reverse the 6 multiplied by x. So I'm dividing this side by 6 and this side by 6 as shown. So I end up with the left-hand side equal to x. And if I cancel top and bottom on the right-hand side by 6, 6 into 6, 1, 6 into 18, 3, I end up with, again, x is equal to 3. So both methods, you see, you get the same results. Okay, so write it down. Make sure you have it and you understand it. Okay, so the next one we're looking at is x over 5 minus 3 over 7 is equal to 1 over 5. Okay. Now, how would we go about solving that particular question? How do we go about solving that particular question? Well, the method that I would put forward to you is a very powerful method, right? And once you understand that method, it will be able to apply it to a lot of other questions that would seemingly be difficult at the start, right? But once you apply it to this, you'll see that it becomes very easy, and then you could apply it to other questions that when you looked at it before, you say, I could never do that question. It's what I call a master key in mathematics. Okay? So the method we're going to use is the following. We'd look at all of the denominators. So we look at the 5, we look at the 5, the 7 and the 5 here on the other side, and we would ask ourselves, what is the LCM of 5, 7, and 5? Could anybody tell me? 35. So that number, which is 35, if we couldn't look at it and find it out, we could work it out. We know how to do LCM. And the strategy is to take that 35 and multiply it by each and every term. So we're going to take the 35 and we're going to multiply it. I'll use brackets to mean multiply. We're going to multiply it by x over 5. We're also going to multiply it by 3 over 7. And we're also going to multiply it by 1 over 5. 35, sorry. Okay? Is everybody clear on that so far? Good. So once you do that, multiplying by a fraction, what we do is we look to see what could cancel out, not so? So what we say is 5 into 5, 1. 5 into 35 is what? 7. Then we say 7 into 7, 1. 7 into 35, 5. Then we say 5 into 5, 1. 5 into 35, 7. Easy so far. And then we do the multiplication. 7 multiplied by x is what? 7x. Minus 5 by 3 is minus 15. Unlike signs when multiply give a negative result. Equal to 7 multiplied by 1 is 7. Could you solve that? What is on the board now? Yes, because we know that from before. So this seemingly challenging problem becomes very simple when you apply that method. Okay? So therefore, we could very quickly run through this. This will be minus 15 plus 15 equal to 7 plus 15. This becomes 7x because these two cancel. And this becomes what? 22. Then we divide both sides by 7. Right? And what do we end up with? This cancels here. So we end up with x is equal to 22 over 7. But 22 over 7 could be reduced. 3 and 1 over 7 or 3 and 1/7. Any problems with that? Make it real easy for you. Okay? So take it down and then we'll do another one. Okay, so we have a next one up on the board. 4x over 9 minus 3x plus 2 over 3 equal to 4 over 9. Okay? So of course, you're looking at this and you're telling yourself, wow, how do we approach that? Well, remember I told you the method we did here is a master key. It opens several doors. If you were able to do this one and you understand it, you could apply the exact same method to this one. Okay? And we'll do it together. Again, if we observe the three numbers, 9, 3, and 9, those denominators, then the LCM of 9, 3, and 9 is 9. Is 9. Because 3 and 9 could go into 9, which means it's a multiple, and it's the lowest common multiple. You could always work it out, the method that we had learned before, you'd get that the answer is 9. So it means that we're going to multiply this by 9, this by 9, and this by 9. So just to be consistent, so we write it back. 9 multiplied by 4x over 9 here, minus 9 multiplied by 3x plus 2 over 3 will be equal to 9 multiplied by 4 over 9. Like that. Okay? And we know 9 into 9 is 1, 9 into 9 is 1. 3 into 3, 1, 3 into 9, 3. 9 into 9, 1, 9 into 9, 1. So, 1 by 4x gives me back 4x minus 3 into 3x plus 2 is equal to 4. So that's what we have to deal with now. Okay? So we use the distributive law here and multiply inside, where the minus 3 will be multiplied by the 3x, and the minus 3 will also be multiplied by the plus 2. Right? That's what we had spoken about before, the distributive law. So here we have 4x minus 3 by 3x is minus 9x, because the signs are unlike. And minus 3 by plus 2 is minus 6, because the signs are unlike. Whenever you multiply or divide numbers whose signs are unlike, the result is negative. And that will be equal to 4. Okay? Then 4x minus 9x is minus 5x. 4x minus 9x is minus 5x. We just consider the numbers, and if one is positive and one is negative, and there's no multiplication or division, whenever you're combining numbers whose signs are unlike, we subtract the smaller from the larger. So we take 4x away from 9x, and we get 5x, and we keep the sign of the larger, which is a negative sign. So we end up with minus 5x minus 6 equal to 4. And then we proceed as we had done before. So this would become minus 5x minus 6 plus 6 is equal to 4 plus 6. We're adding 6 on both sides. So we end up with the minus 6 cancelling with the plus 6. So we get minus 5x is equal to 10. And then how do we eliminate this? Well, we say minus 5x divided by minus 5. Notice we divided by minus 5 and not 5. Is equal to 10 divided by minus 5. Whatever we do on one side, we do it on the other. So this minus 5 will cancel with this minus 5. And this minus 5 will go into minus 5, 1, and go into 10, 2. But because you're dividing a positive 10 by a negative 5, the answer is going to be negative. So this here answer, if we come up here and we write the answer, we write x is equal to negative 2. Because we're dividing positive 10 by negative 5. And if we divide numbers whose signs are unlike, the result is always negative. Hence the reason why we have negative 2. Okay? Any questions there? Okay, so I'm going to put up one here. You're going to use the same strategy, right? You're going to use the same strategy. Right? It's a little different, but even if you don't see how to do it initially, try to formulate a method in your mind until I do it. Right? I'm just giving those who want to try a little opportunity to try it. Okay, so that's the question. Okay, so I'll start you off by letting you know that it's not correct to think about cross multiplying here if you were thinking about it, right? Because cross multiplication could only be done when you have fractions only on either side. Here you don't have fractions only, you have this number here, which is not a fraction. So if it was blocked out like that, and you had a numerator, denominator, with the minus 9 out of the picture, then you could think about cross multiplying. But I wouldn't recommend that. In this case, what you have to do, I'll start you off, but you'll have to say 9 over 1. And having gotten 9 over 1, then the next step will be to go and find the LCM of those three, and you do the same procedure. Multiply it throughout, and you start to work on it. So try it and see what you come up with, right? And we'll look at it in a short while. All right. Okay, we're going to work on this and see how we got the 148, right? So, well, everybody got the hang of finding the LCM, which is of 5, 3, and 1, of all the denominators, 5, 3, and 1. And the LCM of 5, 3, and 1 was what? 15, right? So I was pleased to see everybody at least got the 15. And then the first step, of course, is to take the 15 and multiply it by each term right? 15 here. Right? So everybody did that, at least. And then most people, I think almost everybody did the correct division. So 5 into 5, 1, 5 into 15, 3, 3 into 3, 1, 3 into 15, 5, and then 1 into 15 is 15. So there's no cancelling to be done there. Then what some people forgot is that when you multiply the 3 inside of the brackets, not only is the 3 multiplied by the 3x, but it also has to be multiplied by the 1. Remember we spoke about the distributive law? No, what does this sign mean outside a bracket? Multiplication is understood. Not so? Outside of a bracket. Multiplication is also understood here. Multiplication is also understood here, outside of the bracket. That's what we learned, and that's what we was applying all the time to this point. So we continue to do that. So we say the 3 multiplied by the 3x in the first place there will be 9x. And the 3 multiplied by the 1 is 3. That will be equal to this 5 multiplied by 2. We have to do that first. So 5 multiplied by 2 here will be 10. But we still have the x minus 1 in brackets. So we're just writing it back now. And this minus 15 by 9 will give us minus what? 135. So what do we do next? Let's work out the 10 times x minus 1 as the next step. So let's write back the 9x plus 3 equal to 10 by x is 10x. But don't forget you also have to say 10 by minus 1 too. So that would be minus 10. Minus 135. Then what do we do next? Let us work out this part here to simplify it. So you have 9x plus 3 is equal to 10x. Minus 10 minus 135 is minus 145. Remember, you add the numbers and keep the common sign. So we reach back to something that we're familiar with. But what I taught you guys is that you should get the numbers, the terms in x on the side where it is initially larger. So you notice that 10x is larger than 9x. So the objective would be to get all the x terms on the right-hand side. That way you'd have to deal with less negative numbers. So what I said is, let's take away 9x on the left-hand side, right here. Let's take it away. And then we're going to do the same thing on the right-hand side, because we know whatever we do on the left hand, we must also do it on the right-hand side. So I'm going to minus 9x on the left-hand side. So the minus 9x is going to cancel out with the 9x. And I'm going to minus it on the right-hand side as shown. So I'm going to end up with 3 is equal to, what is 10x minus 9x? That is 1x or x. If I have $10 and I take away $9, I end up with $1. 1x minus 145. So therefore, if I take this and I pull it up there, what happens is 3 is equal to x minus 145. I'll just write it back so we have it clearly here. 3 is equal to x minus 145. So it means then that if I want to get x by itself, like this, it means I have to get rid of the minus 145. To get rid of that minus 145, I have to add 145 on the right-hand side. And therefore, I'll also have to add 145 on the left-hand side. So the result is that this minus 145 cancels with that plus 145. So I have x alone on the right-hand side. And 3 plus 145 is 148. So if 148 is equal to x, x is equal to 148. So this here is your answer. X is equal to 148. Okay, so a student called me across to ask me if 1x is the same thing as x, and the answer is yes. And if you ever forget, you just ask yourself how many x's on the board there, and there's only 1x on the board. So it's the same thing as having 1x in front, or you could leave it out. But then the student also said to me that I have everything correct except that I wrote down the wrong question. Right? And of course, he would be penalized in the exam for doing that. So if you recall, at the very start of our classes here, I said to you that the first thing that you do when you write down a question is what? Check it back to make sure that you wrote down exactly what was in the paper in the first place that you were supposed to take down, so that you wouldn't fall into that problem and end up losing marks that you're not supposed to lose. Okay? Okay, so easy one on the board now, easy one. Minus 7x equal to 49. Okay, work out that one for me. Minus 7x equal to 49. Solve for x. Solve for x. All right, so what I did here was to go back to actually something we had done before in a number of questions as part of the question, right? And I put something that is supposed to be relatively simple on the board. But what happened is sometimes it's so simple it becomes difficult because you're watching it, and so I've seen all kind of strategies like start off like that, and then I see and all kind of thing. I don't know how these things come into it. People just, default to carry over and change sign and all kind of thing. It's the simplest thing in the world, right? It's the simplest thing in the world. Just apply what you learn. And what you learn, if this is minus 7x equal to 49, it means that minus 7 is multiplied by x to give you 49. And what I taught you is you have to reverse what is being done to the x. Remember that? And to reverse what is being done to the x, you have to divide not by 7 as some people did, you have to divide by minus 7. Because whatever you're multiplying by, you have to divide by that same thing. Right? And if you do it on the left-hand side, you also have to do it on the right-hand side. So this is going to cancel with this, because if I divide two numbers whose signs are alike, the result is positive. Right? These two numbers, the same sign. So when I divide them, the result is going to be positive. So this is actually going to be positive 1 when I divide here. And 1 by x is x. is equal to, if I divide positive 49 by negative 7, because one is positive and one is negative, when I divide unlike signs, the result is negative. So it would be negative what? 7 into 49? 7. Some people even forgot what 7 into 49 was. Right? All kind of drama happened in that little time frame there. All kind of thing. I don't know what happened. Jumbie. Right? Jumbie hit. So be careful, right? You all be careful. Take your time. It's easy. Right? It's not hard. Once you know what to do, it's easy. Just follow the instructions. And everything will work out nice and smooth. Okay? So the next one I'm putting up on the board is the last one in this series before we go on to worded problems. And it's 4x minus x minus 1 is equal to 22. 4x minus x minus 1 equal to 22. That's the one we're looking at. Right? And I'm not going to leave you to the wolves. I'm going to help you with this one. Because most people don't know how to interpret the minus sign outside. They don't know what to do with it. Okay? So you will learn today that a minus sign outside the bracket here, this minus sign here, it means minus 1 times whatever is in the bracket. Okay? So from now on, you know that it means that. The minus sign outside the brackets here, right there, means that there's a minus 1 times whatever is there, times. That's what it means. So put that somewhere in a little note, you know, make it to yourself that you wouldn't forget it. Right? Try not to just do it here, know it here, but then later on you forget. Have a little note so when you check it back, you'll be able to get the result. So now this becomes 4x minus 1 by x, and then minus 1 by minus 1. Remember, this is distributive, so it multiplies by both of the terms inside of the brackets. So you get minus 1 by x is minus x, and minus 1 by minus 1 is positive 1. Okay? Because when you multiply minus 1 by x, that's unlike sign, so the result is negative. And when you want multiply minus 1 by minus 1, the signs are the same, therefore the result is positive. That's how we have plus 1 here. And that is equal to 22. So then it becomes very easy. 4x minus x is 3x plus 1 is equal to 22. So that means that 3x plus 1 minus 1 is equal to 22 minus 1. I have to get rid of the plus 1, so I minus 1 on both sides. What happens now? 3x is equal to 21 because the plus 1 cancels with the minus 1 on the left-hand side, and 22 minus 1 is 21. So what happens next? We divide the 3x on the left-hand side by 3 to reverse the 3 multiplied by x there. And we do the same thing on the right-hand side. So we have 21 over 3. So what happens now is that 3 into 3, 1, 3 into 3, 1. We get x on the left-hand side being equal to 3 into 3, 1, 3 into 21, 7. 7 over 1 is equal to 7. So the answer is x equal to 7. X equal to 7. Okay, so very quickly, we'll just touch base on some worded problems, very quickly. So your heading is equation development, word problems with linear equations. Your heading will be equation development, word problems with linear equations. We're going to touch on that quickly now. Equation development, in brackets, word problems with linear equations, close brackets. And we start off with an example, right? The example is, you could write it down. The example is, I'm thinking of a number. I'm thinking of a number, comma. I'm thinking of a number, comma. When I double it, when I double it, when I double it and subtract 13, when I double it and subtract 13, comma, I get 17. I get 17. Full stop. What number did I think of? What number did I think of? I'll read it over quickly. I'm thinking of a number. When I double it and subtract 13, I get 17. What number did I think of? Okay. So you may be able to do a trial and error method and solve it, as well as you may know the correct or the better procedure, which would be to form an equation and solve that equation. Okay? So form an equation and solve that equation. But in forming an equation, we have to use an unknown, right? The unknown is the number that we want to find. That is the number that I thought of in the question. So we could set it up by saying, let the number I thought of be x. Let the number I thought of be x. Then they say, after thinking about the number, I double it. So what if I double it? I'll take the x and I'll multiply it by 2 because I'm doubling it. Then they said, and subtract 13. And subtract 13. So after I double it, I'm going to take 13 away from that result. So minus 13. And they say I get, which means that is equal to, if I get 17, then if I take the number and double it, which means multiply it by 2, and then I minus 13, then I get 17. So that's what we're seeing on the board there. So we form a very simple equation, which is x by 2, which is 2x minus 13 is equal to 17. Right? And because we are so proficient at solving equations, this is an easy one to solve. So here it will become simply 2x minus 13 plus 13 is equal to 17 plus 13. These two cancel out, so I get 2x is equal to 30. And if 2x equal to 30, x is equal to 30 over 2, because I have to divide this side by 2. I have to divide this side by 2, which means x is equal to 15. So you may have been able to get that by simply trying numbers, but this is the method that you go about doing it. Are there any questions with that method? Okay, I close off with one last example and then we close up for the day. We have one more example to do. Okay, we have one more example to do. You all ready to take it down? We're still writing. Okay? Okay. So example 2. The three angles of a triangle are, the three angles of a triangle are open brackets, x minus 20, close brackets, degrees. The three angles of a triangle are, open brackets, x minus 20, close brackets, degrees. So what do I mean by that? X minus 20 degrees, right? So the three angles of a triangle are x minus 20 degrees, comma, open brackets, 2x plus 30 degrees, close brackets, degrees, like what is on the board there. And the third angle is 20 degrees. So to read it over again, the three angles of a triangle are x minus 20 degrees, 2x plus 30 degrees, and 20 degrees as shown on the board. Find the magnitude of each angle. The question is, find the magnitude of each angle. Find the magnitude of each angle. Find the magnitude of each angle. So how would we proceed with this question? What we'd have to do is to find some relationship that connects the three angles. And we all know something about the angles in a triangle. Could you all tell me about the angles in a triangle? Right. That's probably the first rule we learn in trigonometry or geometry, which is the angles inside of a triangle, when you add them up together, they are equal to 180 degrees. Okay? So if we know that the sum of the internal angles right, of a triangle is equal to 180 degrees, then we could use this to our advantage. We could say that this tells us, therefore, if we take x minus 20 degrees and we add to that 2x plus 30 degrees, and we add to that 20 degrees, then all three of them, when you add them up together, they'll give us 180 degrees. That's so? So if we could solve this equation, we could find out what x is, and therefore we will solve our problem. So let's continue. Therefore, we cannot actually execute anything in these brackets, so we could remove them. So we could write x minus 20 degrees plus 2x plus 30 degrees plus 20 degrees is equal to 180 degrees, like this. And then we could start to do some combination. Let us combine all of the x terms. So we have x and we have 2x. Are there any other x terms in there? No. So we say x plus 2x is equal to 3x. So 3x here. Then let us combine the numbers. If we combine the positive 30 and the positive 20 degrees, that will be equal to positive 50 degrees. Not so? So this here is positive 50 degrees. And we still have the minus 20 to consider. So let's put it in there. So we have the x and the 3x gives me, the x, sorry, and the 2x gives me 3x. The 30 and the 20 gives me positive 50, and the minus 20 still has to be considered. That's equal to 180 degrees. So let's work out now what the minus 20 and the plus 50 will be. I have to take the smaller from the larger and keep the sign of the larger. So that should give me positive 30 degrees when I consider the minus 20 plus the 50. And that's equal to 180 degrees. So then, how could we solve that? All we have to do now is minus 30 on both sides. So 3x. If I minus 30 on the left-hand side, it comes out, it's cancelled out. So I just have to minus it on the right-hand side now, like this. Okay, because I minus it on the left-hand side, it's removed. I must also minus it on the right-hand side. So I end up with, if I come across here now, I end up with 3x being equal to 180 minus 30, which is 150 degrees. Okay? And therefore, x must be equal to 150 divided by 3. Because if I divide 3x by 3, I'll get x. And I must also divide the other side by 3 as well. So what happens here is that x will be equal to 50 degrees. X equal to 50 degrees. Can we wrap up and go home now and finish? No. You know why we didn't finish? Read what the question asks here. Have we found the magnitude of each angle? Therefore we can't go home yet. Right? Always remember that. When you think that you are finished, always go back to the initial question and make sure that you have answered it. Right? In this case, we haven't answered it. So what we'll have to do is go back and answer it. Right? So therefore, one angle is x minus 20 degrees, which will be equal to, if x is 50, it will be equal to 50 minus 20, or 50 degrees minus 20 degrees, which is how much? 30 degrees. Then, another angle, two x plus 30 degrees. All right? And that will be equal to 2 multiplied by 50. That's 2x plus 30 degrees. That equal to 2 by 50 is 100 plus 30 degrees, which is 130 degrees. Okay? 130 degrees. And then the final angle is 20 degrees. Or third angle is, and after we do that, then we finish the question. Otherwise, we were not through as yet. Okay? So, with that, we come to the end of the class. I've put up the homework here. I'll write it back here. It's Certificate Maths, Exercise 85, 86, and 87. So your homework will be Certificate Maths, Exercise 85, 86, and 87. Okay? So, that will be it. Don't forget, if you need to review these classes, just look for on YouTube, go up to YouTube and type in Mr. Downer's math classes or Mr. Downer's classes, and you would see it by date. So by tonight, this will be converted and on the internet. Okay? Have a good day. God bless.